Hello friend, thanks for stopping by my channel. In today's lesson, we will discuss about binary trees. In one of our previous lessons, we actually have discussed about binary search trees. Today we'll discuss a different property of the trees, that is how to traverse the trees. To do that, we will use a LeetCode example problem. So the problem is mentioned below, that binary tree level order traversal. So before going into the description of the problem, let's first understand what tree traversals are. So let's actually try to visualize the tree traversal problem. So we'll go back to our blackboard, and here we will create the same tree that LeetCode had created. So let's actually split the screen so we can see it better. So we have the root node at 3, and then we have another node on the left side of the root node, which is 9. And then we have another node on the right side of the root node, that is 20. And then 20 has a left child, which is 15, and it has a right child, which is 7. So now let's focus on this. So that's our tree. And in this particular tree, we have this as our root node. And in any tree kind of data structure, you will be given just a pointer in C or C++ or a reference to this root node. And if we look at the LeetCode structure, right? So the LeetCode structure somewhat looks like this. So every node within a binary tree, it will contain some values. So suppose you start with a root, right? Like if we visualize this in a different way, the root it'll be a small data structure, and it'll have some containers. So it'll have one container or one place for storing the value, which is 3, and then it'll have two more containers for storing the references to its left and to its right child. So this one will contain a reference towards this particular node, and that itself will be another container where there will be value, and then there will be two references, but this does not have any reference, neither left nor right, so both of them will be null. And the right one will basically point to another data structure here where the value is 20, and the left and right, they are basically pointing to another data structures. So if we draw them similarly, it'll look something like this. I'm indicating say slash like null. So if we also indicate null here the same way, then we'll be consistent. So let's say we have a slash null here. So these indicate null, and this right node also, we have the data 7, and then we have two children which are null null. So if you are given reference to only the first guy, you can actually find all the elements that are present in this tree. And let's see how we can do that. The way we can find all the elements in the tree is called a traversal. So let's try to understand the traversal first. So we'll try to understand the simplest traversal, which is called in order traversal. In order traversal. So what is in order traversal? In order traversal, we suppose just we focus our problem only say at this particular scenario. We focus our problem only for the first three nodes. Like you're given a root node, and then you're given 9 and 20. So it's left and right children. We want to focus our problem in that area. And if we want to print all the elements, what would we do is we'll first print the value 9, then we'll print the value 3, then print the value 20. And the way it's happening, first you print your left child, then you print yourself, and then you print your right child. So that's the order for a in-order traversal. And if we repeat the same thing for each of these nodes, we can print all the values of the tree. So let's see how we can do that. So for that, we will actually use a technique called recursion. So let's try to draw the tree again here. So we have 3 here, we have 9, which is the left children, we have 20, which is the right children, we have 15, which is the left children of 20, and then we have 7, which is the right children of 20. So we have a recursive function, say, let's call the function f, and to the function, we just pass this particular reference to the node 3. So we'll indicate like this. So now what this function will do is first it will check that whatever reference that I'm passing to, if it's pointing to null, for example, if root is null, then there won't be any point going further. So that's the first thing that the function needs to check. So what's the function would first do? The function would do a null check. So if it's a null, then you will just stop processing. Otherwise, if it's not a null, then you will continue processing. So we'll see that in detail in code, and that will be better explained there. After that, that's the first step that you have to do in that function. In the next step, you have to do is print the left child. So by printing the left child, what we will do is instead of printing the contents of the left child, we will call the function, because what's the objective of the function? The objective of the function is printing the value of the nodes. So we will call the function with whatever node that it's currently pointing to. So it'll basically point to 3's left child. And that function will again call itself. So this is basically, this function is calling itself, and that this particular step is very important. This particular step is known as recursion, where we are calling the same function inside the same function. We're calling the same function inside it. Now coming back to our implementation. So we print the left child, and for that we do this. Then we actually output or print the content, the root node basically, or the particular node which we are referencing here. After we do that, then in the fourth step, we call the right child of the node. So just this simple step, if we continue to do that, what will happen is we will end up printing all the values of the tree. So let's imagine, or let's try to understand the flow of that function, how it will work. So let's try to use a different color and focus on this particular tree here. So first I'll start with 3. So that's, I'll come here. I won't print anything. So whenever I print anything, I'll just put that in the output statement here. So then first I check if it's null or not. It's not null. I go to its left pointer. So now I'm here. And at this point, I again check if I'm null or not. I'm not. So I go to the next one, which is the left children of this guy, and that is null. So you will immediately return from here. After we return, we print the value of this node, which is 9. So 9 is the first value that gets printed. Then you go to right child of 9, and there also you find null, so you immediately return. and you don't do anything. Now you have executed all the thing that you had to do here, and you go back to 3, and then you print the value of 3. So at this particular juncture, you have printed all the values that are on the left side. So all the values, if you draw a line here, all the values on the left side you have already printed, and also we have printed 3. Now we go to this section here. So we go to 20 and we perform the same operation. We do a null check, and we see that the null check is returning it's not a null. So we go to its left child, and it's not a null. We go to that's left child, and that left child is actually null, so we immediately return not like this. Actually, let's remove this part. Yeah, so let's actually just do this. Yeah. So we come here, and then we print 15, and then we go to the right child of 15, immediately come back, and then we go to 20 here, we print 20, and then we similarly we go to the right child here, check for its left children, check for its right children, and we print 7 here. So see the order that we are printing. We are printing first the left subtree. For each node we are printing its left subtree first, then its right subtree. And left subtree basically means if we create a tree for any given node, if we create a tree with its left child as the root node, it's called a left subtree. So this entire section is the left subtree of 3, and this entire section is the right subtree of this tree. So the right subtree is the subtree. So let's actually name them here. So this one is actually the right subtree, and this is our left subtree. So imagine this particular kind of traversal is very important if we have a binary search tree or a BST. So imagine if we have a BST, and what is the property of a BST? In a BST, the nodes will be organized in such a way you have the root node, and all the values to the left of this root node will be less than that, and all the values to the right of it will be higher than that. So I have some value, for example, say 4 here, and 4 will have another value that is 2 here, and it can have another value that is 6 here. 7 can have another value 10 here, and it can have another one 8 here. This can have another one, say 15. So this is an example of a binary search tree. In this particular case, each node has in its left subtree. So we just discussed what left subtree is. So this is the left subtree of 7, and let's actually use a different color. This is the right subtree of 7. So the left subtree contains all the values in left subtree is less than 7, and all the values in right subtree is greater than 7. So by doing in-order traversal on a binary search tree, so you have a binary search tree here. By doing a in-order traversal on a binary search tree, you actually ensure that you print all the elements that are less than the current element before, and all the elements that are higher than the current element after it. So we print all these values before 7, we print all these values before after 7. So if we actually do in-order traversal on this particular tree, the output comes in this order. We have 2, then 4, then 6, then 7, then 8, then 10, then 15. So basically as if the numbers are all sorted in ascending order. So just by storing the numbers in that structure, we can retrieve them in sorted manner. And this is very efficient to store such a sequence of numbers if we want to quickly find such a number uh, easily. So we can do binary search on the tree, and that's why it's called a binary search tree. So now we have understood the basic concepts of in-order traversal, and let's try to dig into the code, and we'll try to see what are the other kinds of traversals that we can try. So we go back to our editor here. So actually, let's increase the font a bit. I'll use 20 in all the places. Right. Okay, so it's better now. And I'll also create the terminal, a new one. Okay, great. So we are using a very simple setup, um, as discussed in our previous sessions. What we have here is Visual Studio Code, and we execute our programs in command line using Gradle. So our build system is Gradle, so that we can have a multi-file build system, and we can organize our code in any order that we want to put in. But we don't want to use an active ID, and we are not debugging with breakpoints, so that we can better understand the flow. And the more you restrict yourself, or the more you constrain yourself, you will understand the program flow better. So all the kind of debugging that we want to do is via print statements, so we can see how the program is actually executing, and it can help us understand this better. So now let's actually come here, and we'll create a new file under stdlib. Let's call it mytree.java. So first we'll create our package declaration, right? And we'll create a small function for exploring this, which we usually do. So we usually create a static function, but here I'm just creating a method, not a static function. And the way we'll invoke this is we'll just create a new object and then invoke explore on top of them. And let's see what's the output we see from here. I'm here, and let's try to run it from the command line and see what we get the output. So it's actually compiling. Great. So we get I am here printed here. Fine. Now let's actually create that tree structure internally. So we'll create a class called tree node, and this class will have a integer value. It'll have another tree node, a reference to another tree node, which is its left child, and another reference to its right child. And we should have a constructor for this one. The standard constructor would be with just a value, so that we'll just initialize the value to this, and the rest of the references will be all initialized to null. And that's actually redundant to do because they are anyway initialized to null. Or if we have a tree node, if we have an existing tree node from which we basically want to copy all the data, that also we can do. So we can create something like this dot left is equal to another dot left. This dot right is equal to another dot right. So this is just a small utility constructor if we need, but mostly we'll use this one. So first we'll try to create the tree structure that we had in our whiteboard. So let's actually use the cleaner version of the tree structure here. So what we had a root node with 30 with 3, and then we have a left child with 9 and right child with 20, and that had two children, 15 and 7. So let's try to do that here. So we'll create a tree node. We'll call it root with the value 3, and then we assign root left a new tree node with value 9, and we assign another node new tree node. Let's actually keep it side by side so that I can check it here. So we'll have a tree node here, and now root dot right dot left is equal to new tree node 15 root dot right will be new tree node 7. So that's what we have here. Now let's try to quickly implement the in-order traversal function. So what does the function do? As we discussed, we'll call it in order instead of calling f. The function would expect you would pass it a node, a tree node. So it'll first check if node is equal to null. If that is true, then it'll just return. Otherwise, it'll do in order for node dot left. So if it's null, if we don't do the null check, we'll encounter a null pointer exception here. So we need to do that before. And otherwise, we just print the node's val here, and then we come to the right element and print it. So now we have created the tree, and so let's actually try to run it and see what gets printed. So let's clear the screen and run the command. So it's compiling and see the values that are printed here, and let's actually cross check if it is the same thing that we had tried in here. Where did we actually try to print it? Right. So the order that we saw that it should follow is 9, 3, 15, 20, 7, and that is the exact order that it is getting printed here. Now, say if we want to mess up with this ordering, say we want to do this. First print the node's value and then do this. So before doing that, we'll create separate function for that. We'll call that function pre-order. Call that function pre-order. And then we have another function where we call it post order. So this function pre-order and post order, let's try to see what the output actually behaves. But first we have to change the functions, otherwise they're all same. So in pre-order, we first print the value of the node, and then we go to its left child and then to its right child. So if we do it for this particular tree, what will happen is, let's actually take this element. Let's actually take this entire element and we will take it to the right side somewhere, closer to the tree. So we can try to minimize this so that we can drag it. Just copy this and put it here. Cool. Now we can focus on this. So here, if you observe that if we want to do a pre-order traversal, first we will print the value of the root node. So first we'll print the value of 3, then we'll go to 9. Then first we'll print the value of 9, then go to its left and right, and then come back here, go here, first print this, then print this, then print that. So it's basically you're first printing its current value. That's why it's called pre-order, like you're doing the current one first. And the other option is if you do everything and after that you print its your own value. For example, in this, so this is the option for pre-order. I'll call it just pre, and this is for in. And what happens for post order? So for post order, we first go to 9 and we print 9 here. Then we come back to 3, then we go back to 20, then we go back to 15. So 15 gets printed, then we go back to 20, then go back to 7, then go back to 20, and then go back to 3. So the order is completely different. So in this case, the leaf nodes are printed first, and then gradually all the other nodes in higher levels, they get printed. So this is the post order traversal output. So let's actually see if we are seeing that output or not. So I'll change the invocation from in order to post order. So in pre-order, we are seeing 3, 9, 20, 15, and 7. So that's our pre-order. And let's try post order. Post order. All right. So let's try to do that. So in here we see first 9, then 15, then 7, then 20, then 3. So that becomes our order, and that's exactly what we have explained by going through this diagram. So this is actually a very useful way to learn about recursion and data structures, and we can explore different kinds of traversal mechanisms. Actually, in the next session, we will discuss the level order traversal, the problem that we started with, and we will try to see how we can implement that. The solution is a bit convoluted. It's not as straightforward as that. So maybe you could try to think how you can come up with the solution, but we will discuss the solution in the next session. Thanks for joining in. See you in the next session. Bye-bye.